Hey everyone, so let's do that lab. I hope you saw our previous class. In that one we are designed the what we can say GRE. We designed the lab for the GRE and still we need to do the configuration. In our previous class we discussed some GRE lab and we designed the lab, okay, and we discussed the theory about the GRE. So now let's do that lab. So what I will do, we will do the configuration. I hope you remember that one. Okay, so let's do. In our live batch I done some configuration here, so let me check if anything is there we can erase or we can reconfigure. So let me take the CLI of the headquarter and the CLI of the branch as well as the ISP. Theory already we discussed. If you did not watch that one, you can watch that video. Okay, so now we are going to configure the GRE tunnel. Why we are configuring? Because you have the internet here. You want to connect these two branches, that is head office and the branch office, with the help of internet. How you can do? You can do by using GRE. Later we will see DMVPN. In that one we will use the multi GRE. But here we are having only two office, that is head office and the branch office, so we can use GRE because GRE is one-to-one. We can connect two branches. Okay, so nothing is there here in this configuration. We can redo or we can do the configuration. I think I did not save what we done in our live batch, so now I can do from the scratch. That is good. You can also see what we are doing here. So first we are going to assign the IP address. After that we are going to do the GRE configuration. Before doing the GRE configuration, I will show you from our head office. Okay, from our head office we are unable to communicate to the branch office, and from branch office we are unable to communicate to head office. With the help of ISP we are unable to communicate. So what we will do, we will configure the GRE. After that communication will start from the head office to branch office. So let me do the configuration. If you see here, I am in the head office router. So let's start the basic configuration. I will do enable config T. I will change the host name of the router as a head office or headquarter, and then I will assign the IP address. If you see, IP address is nothing but what we can say, we are going to assign to the interface. We are using the fast Ethernet 0x0. Already you know about this one from the CCNA level. So I will do this fast. Okay, whatever IP we plan, I will use that one. If you see here, we plan this IP, so I am using this one 1.1.1 and 255.0.0.0 and write no shut, and I will create one loopback here. I can say loopback 0 and I will give the IP whatever IP we plan to give for this loopback 0. In our what we can say, in the topology we wrote 192. Okay, let me write here IP address 192.168.1.1, give space 255.255.255.0 and write no shut here. Okay, so we assign here, and if you want to check, I will show you show IP interface brief. With this command we can check show IP interface brief. So now our interface is up and we assign the IP address. So let me do the ISP configuration. In the real scenario you will not have the access to the ISP router. You will not do anything to the ISP router. Okay, but here we will do, because this is a lab. So what you need to do, only you need to assign the IP address to the ISP router. That's all. So I will write here IP address 1.1.1.2.255.0.0.0 and I will write here no shut. I have another interface fast Ethernet 1/0 and I will write there IP address 2.2.2.2, give space 255.0.0.0. I will write no shut here also, and if you want I will save the configuration. So we have here the IP address, and here also I can save the configuration. In the branch office we will do the basic configuration. I will write enable config T, host name, whatever host name you want to assign. I will write here branch office 1. Anything you can give, branch office 1. And then interface we have fast Ethernet 0x0. I will write here IP address, whatever IP we put in the our block diagram, I will use same that one. So this is that one. I will write no shut. Then we will create one loopback 0. Okay, because we are going to assign this IP to the loopback 0. 192.168, that one. So I will go here, interface loopback 0, IP address 192.168.2.1. Sorry, 2.1, give space 255.255.255.0, and I will write no shut, but already loopback is up, so no issue. So what we done, just we assign the IP address. Now we need to create the default route also. Example, you will say if any traffic is coming, I will give to the ISP. So you will send all the traffic to this IP. Same thing to the branch office, you will say whatever traffic I am getting from my LAN network, I am going to forward that all towards the ISP to this IP. Okay, so you will create default route, forwarding all traffic to this IP, forwarding from here to this IP. So let's do that one. So I will go here in the head office. How we can configure the default route? I will write IP route. Okay, IP route 0.0.0, 0.0.0. We can say any IP with any subnet mask forward to the ISP. What is the IP of the ISP? 1.1.1.2. Okay, so this way we assign the default route to the headquarters. Same that way we are going to assign the default route to the branch office. We will write IP route 0.0.0.0, that is 0, any IP with any subnet mask forward to 2.2.2.2. Okay, and now what we can do, we can now if you want to check, you can check, you can ping or not. If you are standing here, example, you are standing in the head office, you are sending some traffic, example, you are sending ping to this LAN network of the branch office, and you will write source and from your LAN network, that is you are sending the traffic from your loopback to the branch office loopback. Loopback we are representing as a LAN network. So what I am saying, I am trying to access the branch office LAN network from my head office LAN network. It will not work. Why it will not work? Because we don't have any routing protocol is running in the ISP and also in the our routing, what we can say, our routers. If it is working, it will work, but we cannot do anything, right? We cannot do anything in the ISP router. We don't have any access to the ISP router. So what we can do here, we can do the GRE. If we configure the GRE, then our head office and branch office will start working. So how we can configure, we are going to do that one, so you will have the idea. So we need to create the tunnel, as we discussed in our previous class. We need to create the tunnel. Okay, so as we discussed before, we need to create the tunnel and we need to assign some IP. So what I am going to use, I am going to use this tunnel one, and I am going to use this IP. Okay, I will keep this here, and this one I am going to create tunnel to the branch office, and I am going to give this IP. So let's do. After that we are going to run any routing protocol. So I will go in the global configuration mode. I will write interface tunnel. Okay, here if you see, you need to write interface tunnel and press question mark. You have this range from 0 to this big number. You can create lot of tunnel. You can use tunnel 1, tunnel 2, whatever number, tunnel 0, whatever number you want to give. So I will give tunnel 1. Okay, so now I created the tunnel 1. So first we will create the tunnel. After that we are going to assign the IP address. So what IP we are planning? If you see here in our class before, we told this IP we are going to give to our tunnel. So I will use the same IP. Okay, so I will write here IP address, what IP we told, 172.168. Sorry, not 168, 16.1.1. Okay, and /24 means 255.255.0. and here no need to write, but anyhow I wrote that one also. So this we create the tunnel and we assign the IP address to the tunnel. Then we need to write the tunnel source. Okay, we need to write tunnel source. What is the tunnel source? Your public IP. If you see, this is your public IP. So whatever your public IP, that will be the tunnel source, and whatever your peer, that is your destination public IP, that will be the destination tunnel destination. So I will write here, let me write here, tunnel source is our IP, or you can define your interface also. So I wrote tunnel source is our IP. Then I will write here tunnel destination. Tunnel destination is nothing but your destination IP. So what IP you have? If you see, this is the IP you have. That is your branch office public IP, this one. You are standing here. So this is your public IP. So your public IP, that is nothing but tunnel source. and this is the tunnel destination. You need to define this way. Okay, I will press enter. If you see, now we define the tunnel source, tunnel destination, and our tunnel is also having the IP. Now you need to do the any routing protocol. So what I can do the EAGRP or OSPF. You will not apply the routing protocol to this interface. You will apply to your LAN network and your tunnel only. Okay, you need to remember this one. When you finish this creating tunnel source, tunnel destination, after that the last step is you will enable the routing protocol here. So you will put this LAN network and the tunnel only, not the public IP. You can use any EAGRP, you can use OSPF, you can use, or if you want to do static route, you can do anything. But better dynamic routing protocol is good, because if anything go wrong, automatically they are going to look for another path. Dynamic routing protocol. For that purpose we need the dynamic routing protocol. So let's use the EAGRP. So what I will do, I will write here router EAGRP. Okay, anything you can write AS number 1, and after that no auto summary. If you are using new router, automatically it is disabled, but anyhow I am writing no auto summary. Then destination, and write the destination network ID 192.168.1.0, and if you want to define the wildcard, you can write this way. Okay, see here, if you are using the classful subnet, then no need to define this one. If you define this directly, that is network and network ID, that is sufficient. But if you are using the classless, then you need to define the wildcard mask also, because this one is a classless. This IP belongs to class B, but subnet mask is from class C. So this one we call classless. So here when you advertise that network in the EAGRP, you need to write the subnet mask. So I will press this enter, and then you write again network and whatever IP 172.16.1.0, this is the network ID, and then wildcard mask is 255 0.0.0.255. That's all. This is only the configuration. If you want, I will write here to check show run, okay, section EAGRP, and whatever we configure you can see here. See, we wrote here the wildcard mask for this one also, but he did not put here because this is a classful IP. So for classful IP, if you write directly the network ID also, it will work, no issue. But this is a classless, that's why he put this wildcard mask. Okay, anyhow the configuration one side is done. If you are confused, I can put in the notepad, and you can join our Telegram channel. In that one we are sharing all this, what we can say, configuration, everything. Okay, GRE lab I can write here. So don't forget to join that one, our Telegram channel. Our Telegram channel is having all the configuration, some sample notes, everything we put in that one. Link is in the description of this video. You can use that link and join our Telegram channel. I will put the configuration here because many guys requesting the config file, so I can give this file in our Telegram channel so they can use. They can just directly copy paste. Okay, so here I will just putting the configuration. We need to do the same configuration to the other side also. Okay, so let me write here, and what we done, I am doing same thing. IP root I wrote 0.0.0, then we told 0.0.0.0. we need to forward this to ISP. Okay, this is the R1 configuration. Just now what we done, we wrote interface, okay, tunnel, I give number 1, then we define IP address. IP we told 172.16.1.1, 255.255.255.0, and what we wrote here, we wrote tunnel source. Okay, tunnel source we give our IP, and we define as a tunnel destination. We wrote 2.2.2.1. okay, 2.2.2.1, and after that we do the EAGRP. So router EAGRP 1, okay, and no auto summary, and we wrote network 192.168.1.0, 0.0.0.255, and then I wrote network and network 172.16.1.0, 0.0.0.255. This is the R1 configuration what we use. Okay, what I will do, I will copy the same configuration, I will paste this here. If you see, this is the head office, that is a branch office. Now branch office 1 I can say, and configuration, let's compare here. Here you have 2.2.2. Sorry, let me remove this here from here. 2.2.2.1. okay, and loopback you have this one 2.1, this one, and here forward the traffic towards 2.2.2. Sorry, why 12 it is coming, 2.2.2.2, and tunnel IP is this one. You can use tunnel number anything. In this router if you use 1, in this router if you use 2, no issue, it is locally significant, you can use anything. Anyhow I am using same number, and here you will have the source will become destination, destination will become source here. Okay, so here you will change this, and here you will put as 1.1.1.1, and here EIGRP this will be same, and here this will also same. EIGRP configuration is same. Let's revise here. You created interface tunnel 1, you assign this IP there, and this is a subnet mask, and tunnel source is this IP, tunnel destination is this IP, router EIGRP1, no auto summary network, and this is the network, your LAN network. Your LAN network is 2.0, this one, see here 2.0, this is your LAN network 2.0, and other tunnel is 172.16.1.0, and this is a wildcard mask. You no need to advertise this public IP. We will not advertise this public IP, only our LAN network. If you have 2 or 3 LAN network, put all that LAN network in the EIGRP and then put the tunnel. Okay, so this configuration is good. I will copy and paste in the second router, that is a branch router. Already we created default route, we assign the IP address, so no need to do that one. Now only we need to do the tunnel configuration. So here EIGRP spelling mistake I done, so let me correct here EIGRP. okay, so typing error here also I will correct EIGRP. Where is RP? Let me paste this now. Okay, so I will go here, I will paste that. Now it is good. Let me make this big, and if you see this one is okay, no issue, only spelling mistake here, that's why we have this issue. But now we type, this one is working good. So you have the neighborship up, tunnel is up, and now you can ping. Before ping is not working, now it will work. So you can go back and check. Before this one is not working, now it is working. So our lab done successfully. If you see what we done here, I am pinging from my LAN network to the branch office LAN network, and it is communicating. We did not do anything here. What we done, only we create the tunnel. Like this we have tunnel from here to here. It look like directly they are connected, but here lot of ISP router we have here. We have lot of ISP router in the ISP cloud, and if you type trace route also, it will show you like you are connected directly. If you write here in the head office trace route 192.168.2.1, okay, source 192.168.1.1, and do the trace route, it will show you like you are directly connected. Okay, anyhow it will come, it will take some time, or we need to disable no DNS lookup, so it will come fast, but anyhow you can check, it will show you like it is connected directly. Okay, see, it is connected directly. Let me show you. It is showing like you are connected directly. How you know directly means, I do trace route from here to here, so only they are showing traffic is going from here to here, that's all. That is this. So it look like you are connected directly. But if you capture the traffic here, that is a problem. If you capture the traffic here, fast Ethernet 0x0, let me show you. If you capture, remind me later. Here you can see all the packets is visible, because EIGRP you can see here. We are doing GRE. GRE is not going to do the encryption, that is the problem. If I send the ping, all the packets whatever you are sending, that is visible. if any attacker is sitting in between, he can capture our packets, whatever data is going. If you see this tunnel IP, everything is, you can see everything is visible here. Everything is visible here. So this is a drawback between the GRE. So what we can do, let me ping and show you the packets. If you see ping I am doing, and you can see the ping, whatever traffic is going, this ping is also visible. If you click here, this is a LAN network of the head office, LAN network of the branch office. It is visible. Anyone can capture and they can check what we are doing, what we are sending, what is the source IP. This is our public source and destination IP. This is our private IP. Everything is visible to everyone. If any attacker or hacker is sitting anywhere, he can easily read our data. So what we will do to secure this one, we are going to put the IPsec. Okay, we are going to put the IPsec over on the GRE, over the GRE. First we configure the GRE. Over the GRE we are going to put the IPsec here. So IPsec is going to secure that one, and IPsec is going to do the encryption. So data will be encrypted, and if you check in this one, all the data will be encrypted. You cannot see this. Okay, so in our next class we are going to do that one. We are going to learn how we can configure the IPsec in this router, head office and the branch office. I hope you enjoy this video. In case if you have any query or any doubts, you can join our Telegram channel, join our WhatsApp, and you can follow us on the Instagram, or you can send the query in the comments, or you can WhatsApp us. Okay, join our Telegram channel. I'm going to share this all configuration there, so it will be helpful for you to understand this. Thank you. Bye.